All right, so drawing it in standard position. Standard position means that the initial side, remember there are two sides, there's the initial side and then the terminal side of your angle. The initial side is always along the positive x-axis. And then you're going to rotate either in a positive direction, so that's the positive direction, and that is the negative direction. So since this is a positive 330 degrees, we're going to rotate in the positive direction. So this is going to be 90, 180, 270. Okay, so I know that each quadrant's about 90, so if I split it into 3, because I have a 90 left, or 60 left, right, 270, 330 minus 270 is 60. So, split that up into thirds. And so then therefore that's going to be, almost looks like 45, but you get the gist. If I did equal 30, it's hard to do with my pen. But that's about 330. It should be actually maybe closer to there. I think that's probably better. Minus 270. So initial side always positive x-axis. 90, 180, 270. So it's always along I went in the negative direction when I drew it. Now when it comes to pi is easier than we think. So this number here is how you cut up how you cut up the pi. Now pi is 180 degrees. So I'm cutting up the quote-unquote 180 degrees or quote-unquote pi into fourths. So that means that the pi side would just be that side, right? That's getting cut up into fourths. And I want 3 of them. So here's my initial side. Count 1, 2, 3. There's my terminal side. That's 3 pi fourths. So negative pi third. So that means that I got to cut up the pi into thirds. So I don't know why I did that, but anyways, so here's my initial side, and it's rotating in the negative direction. So there's my third. And then negative 2 pi, initial side, rotates all the way back. Now, it's important to draw the direction that it's rotating because of the fact that it's positive, negative. And that's the reason why you should draw your arrow, and then so you know how it's being rotated. Solve the inequality. Remember, we pretend it's an equal sign. I'm going to add it to the other side. Break it up. So 2x plus 1 equals 5. And then negative 2x plus 1 equals 5. Solve. You get x equals 2. And then if I divide the negative, x equals negative 3. Put that on a number line. Open circle. Now we test true or we test false. If I plugged in negative 4, you're going to get false. If I plugged in 0, 0 plus 1 minus 5 is less than that, is true. If I plugged in 3, 7 minus 5 is 7 minus 5 is 2. 2 is not less than 0, so that's false. And so your answer is going to be from negative 3 to positive 2. X squared plus x plus 1. So there's no way to factor it, and so we need to use the quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now what you should get from here is that your answer is going to be imaginary. So if it's imaginary, there are no real solutions that you put on the number line, and so you can test any value to see if it's true or false. And so if I plugged in 0, I get 1 is greater than 0, it's true. Everything is true, so it's actually infinite number of solutions, and those solutions are from negative infinity to positive infinity. And it's because the graph, if that's accurately drawn, it's above 0. The entire graph is above 0. There is nothing below 0, and that's the reason why it's negative infinity to positive infinity. So for this next one here, we have x squared and then minus 3x equals 2. And then we have, I distributed it. I probably shouldn't have, but I'll write the other one. So negative x times x minus 3 equals 2. So distributing this, I'm going to get myself some room. It's quadratic, so I want to bring it over. So the factors of negative 2 that add to 3. And then on the other one, I get negative x squared plus 3x equals 2. If I bring everything to the other side, I'm going to get x squared minus 3x plus 2 equals 0. Okay. So for this one, I can factor into x minus 1 and x minus 2. So I'm going to get x equals 1 and 2. For the other one, it doesn't factor, so using the quadratic formula, negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So you're going to want to enter that into your calculator. It looks like it's going to be positive, so it's going to be 3 plus or minus 9 plus 8. So that's 17 all over 2. So 3 plus or minus the square root of 17 all over 2. So we're going to want to find that, and we're going to put that on a number line. So that's going to be minus 0.56 and 3.56. And so those are the values that we're going to put on the number line. So minus 0.56, we got 1, we got 2, and we got 3.56. I think this is a really good hint. Open circle, and then you're going to take each of those and you're going to plug them in and see if it's true or false. So if I plugged in negative 2 times whatever it is that going to be less than 2? That's going to be true. If I plugged in 0 times whatever it is also going to be true. If I plugged in 1.5 times, that's a good question. So 1.5 times 1.5 minus, so 1.5 times 1.5, is that going to be less than 2? And it is not, so that's going to be false. And then I have between 2 and 3.56, so I'm going to say 3. So 3 times 0, 3 times 0 is 0, 0 less than 2, that's going to be true. And then 4 times 1, that's not less than 0, so that's false. So this is my answer, this is my answer, and this is my answer. And so that's going to be negative infinity to negative 0.56 union negative 0.56 to 1 union from 2 to 3.56. Factor completely. We haven't gone over this yet, so skip. For the 9m squared minus 16, that's going to be 3m plus 4, 3m minus 4. And then a times c, factors that add to b, you got that. And then we haven't gone over this yet, so also skip.